everyone. Today we will discuss a sample problem from Fluid Mechanics and Hydraulics, Chapter 5, Fundamentals of Fluid Flow. Oil flows from a tank through 135 meter of 140 millimeter diameter pipe, then discharges into air as shown in the figure below. If the head loss from point 1 to point 2 is 530 millimeter, determine the pressure needed at point 1 to cause 14 liters per second of oil to flow. Let's look at our diagram. The specific gravity of oil is already written, and we need to know the pressure at point 1, which is the pressure in the air chamber. Now, let us identify our given. We have position at point 1 is equals to 15 meters. Position at point 2 is equals to 25 meters. Gravity of oil, which is 0.80 meter. Geometric flow rate is equals to 14 liter per second. Since we are dealing with a metric unit, we must convert the liter to cubic meter. Thus, 14 liter per second multiplied by 1 cubic meter over 1,000 liters. This will become 0.014 cubic meter per second. Time, we need to establish what formula we will use. To get the head loss, we have an equation of P from point 1 minus energy from point 2 is equal to head loss from 1 to 2. Changing our equation, we can get E sub 1 minus head loss 1 to 2 is equal to E sub 2. This would become our first equation. And what we learned from our class, we know that energy head is equal to velocity squared over 2g plus the pressure over the specific weight plus our potential energy due to position, which is represented by z. Putting this to our equation, we will now have v squared over 2g plus p1 over specific weight plus z1 minus head loss 1 minus 2 is equal to v sub 2 squared over 2g plus p sub 2 over y plus z. Since we now have our formula, let us start solving the problem. We are asked to solve for the pressure at point 1. Since this is a tank, our velocity would be 0. Thus, this part would equal to 0. In this problem, the head loss is given with a value of 530 millimeter or 0.53 meter. And we will use the elevation at point 1 as our z sub 1. At the right side of our equation, we don't know the value of our velocity at point 2, but we have the volumetric flow rate at point 2, which is 0.014 cubic meter per second. Using the equation Q is equals to V times A, we can get V sub 2 is equals to Q sub 2 over A sub 2. Plugging all the values for this equation, we have V sub 2 is equals to 0.014 over the area, which is pi over 4 times the diameter of 0.14 meters squared. This is squared since V sub 2 is squared all over 2 times the gravity of 9.81 plus 25, our pressure 2, which would be 0. Or P1 over gamma is equal to 10.57 meter of oil. We need to isolate P1. We have P1 is equal to 10.57 times gamma, which is equal to the specific gravity of oil, 0.80, times the density of water, 1000, and the acceleration due to gravity, 9.81. Is equal to 82,953 Newton per meter squared. Newton per meter squared is just equal to Pascal. Thank you for listening, and don't forget to subscribe and like this video. And guys, see you on our next video. Thank you.